Somewhere above you right now, past the roof, past the weather, past the moon and the sun and every planet you could name, there is a small machine, about the size of a car, falling through the darkness. It has been falling for almost 50 years. Tonight, as you settle in to listen, it is roughly 25 billion kilometers from the room you're in, and it is still patiently trying to reach us. Its transmitter is weaker than the bulb inside your refrigerator. By the time that signal has crossed all those kilometers of emptiness and arrived at an antenna here on Earth, it has faded to less than a billionth of a watt, a signal so faint it should be lost entirely in the background hiss of space. And yet, night after night, we still find it. The voice of the farthest thing that human hands have ever made. A radio signal is a kind of light, and light is the fastest thing there is. And even so, its voice takes almost a full day to reach us. When we listen to it tonight, we are hearing something it said yesterday. If we sent a reply, it would not arrive for another day after that. It is so far away that the simplest possible exchange with it, one question, one answer, takes the better part of 2 days. And sooner than you might think, it will fall silent for good. Its name is Voyager 1. We built it in the 1970s and sent it in the late summer of 1977 to do something no one had done before, to fly out past the giant planets and see them up close. It found volcanoes erupting on a moon of Jupiter. The rings of Saturn, which from Earth had always looked like a single smooth band, broke apart under its cameras into thousands of separate ringlets. And then, its work among the planets finished. It simply kept going, outward and outward, in a long straight line, until it reached the place where the wind from the sun finally thins away to nothing and crossed over into the space between the stars. Nothing we have ever built has gone there before it. Almost everything about where it is now is hard to hold in the mind. It is moving at 17 kilometers every second, and it is not slowing down. It will keep going on and on, in more or less a straight line, long after everyone listening tonight is gone. Inside it, a small amount of plutonium has kept it warm and awake for half a century, and that warmth is very nearly used up. Its computer carries a few tens of thousands of bytes of memory, less than it would take to store a single photograph on the phone beside your bed. And to hear it at all, the people who look after it now must point one of the largest radio dishes on Earth at an empty-looking patch of sky and wait most of a day just to catch it breathing. But the strangest thing about Voyager 1 is not how far it has traveled or how faint its voice has grown. The strangest thing is bolted to its side. It is a record. A golden record, the kind you might once have set on a turntable, sealed beneath an aluminium cover and fixed to the outside of the spacecraft, facing out into the night. Pressed into its grooves is a portrait of the world that made it. There is music, about 90 minutes of it, from Bach to a Bulgarian shepherd's song, to the sound of a Chuck Berry guitar. There are spoken greetings in 55 languages, one of them in the voice of a small child. There are the ordinary sounds of the planet itself, rain and surf and thunder, footsteps, a kiss, a mother murmuring to her baby. And there is the sound of a single human heartbeat, recorded by a young woman who in the days she sat for it had just fallen in love. It was placed there for a reader who may never exist. Perhaps tens of thousands of years from now, something will find this record drifting between the stars and lift it and hold it and wonder. Perhaps nothing ever will. There was no way to know. We sent it anyway. There is something worth sitting with here before we go any further. For almost the entire history of the universe, matter simply did what matter does, with no one anywhere to notice it happening. And then, on one small and unremarkable world, some of that matter arranged itself into beings who could look up and wonder and build. And when those beings finally made something that could leave, really leave, and never come back, The first thing they thought to do was to gather up their music and their languages and the sound of one another's hearts and send it all outward in the hope that it might someday be found. The farthest thing we have ever made is not really a machine. It is a message about who we were. We're going to follow this one machine the whole way through, from before it had a name or a shape, out to the 4 planets, past the edge of the sun's reach, and into the slow, gentle fading that is coming for it now. There's no hurry tonight. It's a long way, and we'll take it slowly. If this is the kind of journey you like to take at the end of the day, you're welcome to stay for it. And if you'd like to be here when the next one goes out, you can follow along. And if you feel like it, before you drift off, leave a word to say where in the world you're listening from and what the hour is where you are. But all of it, the record, the coming silence, the 25 billion kilometers, comes later. To understand how a machine ends up in the space between the stars, carrying the sound of a heartbeat, we have to go back to the very beginning. And the beginning is not a rocket or a launch pad. It is a young man at a desk on a summer afternoon in 1965, working through a quiet piece of arithmetic that would open a door in the sky. His name was Gary Flandreau, and in that summer, he was no one in particular. He was a graduate student in his 20s, spending his days at the Jet Propulsion Laboratory in California, in the years when the whole business of sending machines into space was still young and half improvised. Someone had handed him one of those loose, open-ended problems that tend to land on junior desks to find good ways of sending a spacecraft out to the far planets. And so he did what you did in 1965, in the days before a computer was something that sat on the desk in front of you. He took the long tables that told where each planet would be, decade by decade, and he began to plot them out by hand. It was slow, patient work, the kind that can fill a summer, and somewhere in the middle of it, a pattern rose off the page that he had not gone looking for. In the late 1970s, more than 10 years ahead of him then, the 4 giant planets of the outer system would drift into a rare arrangement. Jupiter, Saturn, Uranus and Neptune, strung out one behind another along the same wide curve, all gathered on the same side of the Sun. On its own, a line of planets is only a curiosity. What made this one precious was a trick the engineers around him were just then learning to use. A way to reach the outer planets without the impossible weight of fuel it would otherwise take. The giants lie so far out, and the Sun pulls so hard close to home, that a spacecraft burning its own fuel the whole way would have to be built impossibly large, or would take most of a human lifetime to arrive. Unless, that is, it let the planets do the throwing. Here is how the throw works. A spacecraft falling toward Jupiter gathers speed as it comes, the way anything does when it falls towards something enormous. It swings in close and curves around the back of the planet, and this is the sleight of hand, because Jupiter is not sitting still, but moving forward along its own slow orbit. It drags the little machine along as it passes and releases it faster than it arrived, flung onward in a new direction. Jupiter alone could add 10 kilometers a second to a spacecraft's speed and pass it along towards Saturn. Saturn could add several more and hand it to Uranus, and Uranus to Neptune. Each planet a push, and each push costing not a drop of fuel. Under its own power, a probe crawling out to Neptune might take 30 years to arrive. Borrowing from the planets, the same trip could be done in 12. And the planets never feel the loss. Whatever speed the spacecraft gains, the planet gives up. That much is fixed and cannot be cheated. But Jupiter is so much heavier than anything we could ever launch that surrendering 10 kilometers a second slows it in its orbit by an amount no instrument on Earth could ever detect. You could throw 1,000 spacecraft past Jupiter, one after another, and never once catch the planet stumble. Here, then, was the gift hidden in Flandreau's line of planets. They were about to fall into an order so convenient that a single craft, launched in a narrow handful of years at the close of the decade, could be thrown from one to the next and the next. Jupiter to Saturn, Saturn to Uranus, Uranus to Neptune, in one long, unbroken fall from the largest planet to the outer edge of them all. An arrangement like that is rare. The four giants line up this way, spaced so neatly that one craft can step between them only about once every 175 years. The last time it came around, give or take, Thomas Jefferson sat in the White House and Napoleon's armies were crossing Europe. There were no railways yet, no photographs, no way anywhere on Earth to catch a sound and keep it. And once the brief window at the end of the 1970s had passed, the same door would not open again until long after you and everyone you know are gone. This was the chance of several lifetimes, and it was coming whether or not anyone was ready to meet it. The plan that grew from those penciled pages was bold enough to earn a name to match: the Grand Tour. Not a single spacecraft, but a small fleet of them, launched across a few years and spreading out to every world in the outer system, Jupiter and Saturn, Uranus and Neptune, and far off Pluto beyond them all, still counted a planet in those days. It would have been the widest reach of exploration anyone had ever attempted. And then, in the way of these things, it was cancelled. By the early 1970s, the money had run thin, and the full Grand Tour, with its fleet of ships, was judged too costly and quietly shelved. The rarest launch window in nearly 2 centuries was drawing close, and for a while it seemed no one would be there to use it. What came through the budget cuts was smaller and far more cautious. In place of the fleet, only 2 spacecraft were approved, built on the bones of an older, well-tested design, with an official mission that promised to reach no further than Saturn. For most of the years it took to make them, they went by the plain, forgettable name of Mariner Jupiter-Saturn. Only in the spring of 1977, a few months before they left the ground, were they finally given the name they would carry to the end: Voyager. But the people who built them had never quite let go of the door in the sky. They shaped the 2 of them with a quiet stubbornness, so that one, if it came through Saturn whole and healthy, might still press on toward the farther planets and finish the Grand Tour after all. For now, though, all of it, the tour, the throws, the 4 planets in their rare and narrow order, existed only as lines on paper, a run of numbers describing a road that nothing had ever travelled. Before any of it could become real, someone had to build a thing that could survive that road, cold enough, tough enough, and clever enough to last out there for decades and to go on speaking the whole way home. What they had to build was, in its way, a kind of animal, a body shaped for a life that no living body could survive. It would have to last for decades in the cold and the dark, further from the sun's warmth than anything had ever gone on working. It would have to power itself, steer itself, mend its own small hurts, and above all keep speaking across a distance that grew wider every year, with no hand ever able to reach out and set it right. Nothing alive could do any of that, so they built something that could. It did not look like much. The central body was a squat, 10-sided drum, no larger than a small car, and weighing a little over 800 kilograms, with thin booms and antennas reaching away from it in different directions, some of them 10 meters long and more. It looked less like a ship than like some spare, unlovely insect made of foil and metal, which, in a sense, was exactly right, because like an insect, every part of it had been shaped by the place it was going to live. Out where it was headed, sunlight is next to useless. Past Jupiter, the sun shrinks to the brightest star in a black sky and gives almost no warmth at all. The solar panels that keep satellites alive near Earth would have hung out there dark and dead. So the spacecraft had to carry its own fire. Held out at the end of one boom, away from everything delicate, was its heart. A nuclear battery, a lump of plutonium no bigger than a carton of milk, sealed inside metal. It was warm for a simple and slightly unsettling reason. It was falling apart. Atom by atom, the plutonium was breaking down, and each tiny breakdown gave off a breath of heat, and that heat, turned into electricity, was the machine's whole life. There were no moving parts to wear out, nothing to grind or seize, only a steady, patient warmth. At the start, it produced about 470 watts, less than a kitchen kettle draws to boil your morning water, and that was all the power the spacecraft would ever have. But there was a catch folded into that heart, present from the very first day. The same slow decay that warmed it was also, quietly, using it up. From the moment the plutonium was sealed inside, it began to cool, losing around 4 watts of power every year without a single pause, and with nothing anyone could ever do to stop it. Roughly every 88 years, half of whatever warmth remained would be gone. The heart that made the machine possible was the very thing that promised from the beginning that one far-off day it would fall still. They built a body meant to outlast its makers and set at its center a slow and certain ending. For all that warmth, the mind it fed was astonishingly plain. The spacecraft's entire memory came to about 68 kilobytes. A single, ordinary app on the phone in your pocket uses thousands of times more than that, merely to open. It thought slowly, ticking through several thousand instructions a second, where a modern machine races through billions. But it did exactly as it was told, and it did not forget, and out in the dark, faithfulness matters more than speed. It had one part it would protect above all the rest, a golden dish almost 4 meters across, that it kept turned always toward home. Everything it would ever see or measure or feel had to travel back through that dish as a thread of radio too faint to imagine and to be heard at all. The dish had to stay aimed, patiently, precisely, at a single pale point of light that was the Earth. Wherever it went, however far, it would keep its face turned back toward us. Around its body it carried 11 instruments, and these were its senses. 2 were eyes, cameras, to photograph the worlds it would pass. The others were stranger, built to feel a place nothing living could endure, to measure magnetic fields, to count the thin sleet of particles streaming off the sun, to listen for the faint ringing of the near-empty space around it. Senses for the cold and the dark, where there is almost nothing to see and everything to notice. And from the beginning, it had someone to listen for it. A young physicist named Ed Stone became the mission's lead scientist 5 years before it ever left the ground, and he stayed at his post, watching over its long journey for half a century, very nearly the rest of his life. The machine he helped send out has been warm and awake and speaking since before some of you listening tonight were born. They had built, in the end, something close to a paradox, a body of real cleverness and almost limitless patience, able to think for itself, heal itself, and hold a conversation across the emptiness for longer than a human career, and carrying at its very core the one flaw no cleverness could mend, a warmth that had been fading from the day they sealed it in. But a body, however clever, however faithful, is only a vessel. And before they sent this one out to spend itself in the dark, the people who made it did something stranger and far more human than any piece of its engineering. They gave it something to carry, not an instrument, not a tool, but a message. They gathered up the sounds of our world, fastened them to the spacecraft's side, and told it to carry our voices outward into the long silence between the stars. The idea had come from one of the mission's own engineers, a man named John Cassani. The spacecraft was going further than anything ever had, and might well outlast the people who built it by a stretch of time none of them could picture. So why not attach a message to its side, something to say who had made it and where it had come from? Cassani handed the problem to Carl Sagan, and Sagan gathered a small band of friends around him, and between them they were given a few weeks and almost no money to do a thing that ought to have been impossible, to speak once and for all for the whole of humanity. Consider what that actually asks. You are writing not to another person, but to a stranger who shares nothing with you. Not your language, not your body, not even your sense of time. There is no telling when the message might be found, 100 years from now or 100 million. And once it is sent, nothing can be added or taken back or explained. You get one record and one chance, and then it is gone for good. What they made was, of all things, a phonograph record, an actual golden disc of the kind you might once have set spinning on a turntable at home. Onto it, they pressed 3 things: a set of pictures, a run of sounds, and a long stretch of music. Each was an attempt to answer, from a different angle, the same enormous question: what a human being is, and what it is like to be here. The pictures came first, more than 100 of them, encoded so that a finder clever enough might one day turn them back into images. And here the difficulty of the task shows plainly, because how do you show a stranger what you are? They chose a simple outline of a man and a woman standing together. They chose the spiral of DNA, the thread that every living thing on Earth is written in. They chose the growing shape of a child in the months before birth, a mother feeding her baby, people eating and running, a house, a city, and the Earth itself, blue and wrapped in cloud, seen from space. There were diagrams too, of where our planet sits among the others, of the counting and the chemistry a stranger would need in order to make sense of the rest. It is a strange and touching thing to watch a species try to draw its own portrait for eyes it will never meet. Then came the voices. They recorded greetings in 55 human languages, reaching deliberately across the whole span of what we have ever spoken. From Akkadian, a tongue last heard in a Mesopotamian city some 6,000 years ago, to languages still alive in the world today. The greetings themselves are mostly small and ordinary and unbearably kind. Peace. May all be well. We wish you happiness. And near the end of them, a single child steps up to the microphone, a 6-year-old boy, as it happened Carl Sagan's own son, and says simply, "Hello from the children of planet Earth." That boy is a grown man now, and will one day be gone, and somewhere out past the planets, his 6-year-old voice is still saying hello. And folded quietly beneath the human greetings, almost as one more language among them, they laid the long, looping song of a humpback whale, so that the record would carry not only the voices of people, but at least one voice from the rest of the living Earth. But it was the music they argued over most, and cared about most, because music might be the one thing on the record a stranger could actually feel, understanding nothing else. They had 27 pieces to work with, about 90 minutes in all, and into that narrow space they tried to fit the whole musical life of the planet. There is Bach, and there is Beethoven, a slow grave movement for strings chosen partly for its sorrow. There is a night raga sung by a great Indian voice, a men's chorus from Georgia, panpipes from Peru, a chant sung by Navajo singers, and a Bulgarian shepherdess whose single voice seems to carry a whole cold mountainside. And there is Chuck Berry, playing Johnny B. Good, because someone insisted that whatever else we were also this, loud and young and pleased with ourselves. Not everyone approved. When rock and roll was proposed, one of the folklorists helping to choose the music objected that it was adolescent. Sagan's reply has outlived the argument. There are a lot of adolescents on the planet. So the guitar stayed, and near it they placed something from the far opposite end of human feeling, a blind street singer's wordless, aching hum of a song, an old piece of American blues with no words at all, just a voice and a slide guitar mourning something it never names. Of everything on the record, it may be the one a stranger would understand best, because grief needs no translation. That is the astonishing arithmetic of the thing. One small disc, spinning silently on the flank of a machine, was made to stand in for billions of people, and every century of them who came before, every language, every kind of music, every way of being alive. And all of it is out there still, moving together through the emptiness. A shepherdess's lament and a rock and roll riff, an ancient greeting and a child's hello, a whale's song and the shape of a strand of DNA, flying side by side at 17 kilometres a second, further from home with every breath you take. And yet, for all its pictures and voices and music, the record was still missing something, the hardest thing of all to set down. The people making it wanted somehow to capture not just what a human looks like or sounds like, but what it feels like to be one, to be alive and awake and in love. And to do that, one of them was about to try something no one had ever attempted. On a June afternoon in 1977 in a hospital in New York, a young woman lay very still while a machine recorded the faint electricity of her thoughts. Her name was Anne Druyan, and she was the creative director of the record, the one who had helped gather its music and its voices. And she had thought of an answer to the one thing still missing from it. If the record was meant to say what it is like to be a living human being, then perhaps the truest way was not a picture or a word at all, but the actual signals of a living body, the electrical storm of a brain, the beat of a heart, the pulse of blood in the veins, the very things moving through you now as you lie there listening, set down while that body simply felt what it felt. So they wired her to the instruments, and for about an hour she lay there and let her mind move down a list she had prepared. The history of the earth, the rise and fall of civilizations, the long climb of human thought. And at the very end, something she had not planned to record at all. 2 days earlier, over the telephone, she and Carl Sagan had confessed that they were in love. It had come over them suddenly and taken them both by surprise, and in the same breathless call they had decided to spend their lives together. And so, while the machines listened to her heart and her brain, part of what moved through her in that hour was the sheer astonishment of it, of having just unexpectedly fallen in love. They compressed the hour down to about a minute of sound and slipped it in among the record's other voices, the bird song, the greetings, the music. It is there still, somewhere out beyond the planets, the recorded rhythm of one woman's heart on one particular afternoon. A heart that once beat much as yours is beating now, is travelling outward through the emptiness and will go on travelling long after that heart, and everyone who ever knew it has stopped. Sagan used to wonder whether, 1 billion years from now, some far-off mind might find the record and read the brainwaves of a person in love. Who knows, he said. 1 billion years is a long time. That number was not a figure of speech. The record had been built to last that long, a disc plated in gold, meant to survive the slow scouring of space for longer than any mountain range, longer than the pyramids, very possibly longer than the species that made it. And that raised a problem, one they had to solve on the outside of the disc, on its cover. A message that might drift for 1,000 million years is worthless if whoever finds it cannot tell where it came from, or how old it is, or even how to play it. So they turned the cover into a set of instructions, written not in any language, but in the one thing a distant mind might truly share with us, the plain physics of the universe. To show how to play it, they drew the record and its needle, and gave the speed to spin it. But a number means nothing without a unit, so they tied their unit to hydrogen, the simplest and most common atom there is, which flips between two states at one fixed and universal rate. Any physicist anywhere would recognize that rhythm and could use it to read every figure on the cover. To show where the record came from, they drew a burst of lines spreading out from a single point, each line standing for a pulsar, one of those collapsed, spinning stars that sweep the sky with a beam of radio, each ticking at its own exact and unmistakable rate. 14 of them, marked with their rates, would let a finder work backwards to the one place all the lines meet, our sun. And because pulsars slow over the ages in a knowable way, the same small map records not only where the record was made, but when. And to mark how far it had come through time, they fixed to the cover a patch of uranium, a metal that decays at a steady, dependable pace, half of it gone in some 4.5 billion years. A finder would need only to measure how much remained to know how long the record had been adrift. It is a clock built to be read across the lifetime of a star. There were words on the mission too, from the world it was leaving behind. The American president, Jimmy Carter, sent a short message to travel with it. It was, he wrote, a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts and our feelings, and we were attempting to survive our own time so that we might live into theirs. The Secretary General of the United Nations, speaking for 147 nations, added only that we stepped out into the universe seeking peace, and that we took the step with humility and with hope. And then, at last, it was time to let it go. There were 2 of these spacecraft, in truth, twins, built side by side. The one called Voyager 2 rose first, on the 20th of August 1977, atop a Titan rocket that trailed fire the length of a football field. Voyager 1 followed 16 days later, on the 5th of September, on a steeper and faster road, so much faster that by that December it had already caught its sister and passed her in the dark. Taking a lead, it has never once surrendered. Somewhere in the final hours before it flew, human hands touched it for the last time, checked it over, and stepped back. Then the engines lit, and the machine we had made, carrying a woman's heartbeat, a child's hello, and the music of a whole planet, climbed up off the Earth, the same world you are resting on tonight, and did not come back. Ahead of it, brightening slowly in its cameras over the months that followed, was the first thing it had been sent all this way to see. The largest, the heaviest, and the most violent world our sun has ever held. For 1.5 years, it fell silently between the worlds, and ahead of it, Jupiter slowly changed from a bright point of light into something enormous, a banded, swollen, restless planet, wrapped in cream and rust-colored clouds that never once stopped moving. By the time it arrived, in early March of 1979, Jupiter filled its cameras from edge to edge. There is no honest way to make the size of it feel ordinary. Pour every other planet in the solar system into Jupiter and there would still be room to spare. More than 1,000 Earths would fit inside it, and it weighs more than all the other planets put together. And toward this thing there came falling a small machine of foil and wire, no bigger than a car. On the 5th of March, it made its closest pass, sweeping less than 300,000 kilometres above the cloud tops. Close, by the reckoning of space, though still most of the way from the Earth to the Moon, and as it passed, it looked down into the most famous storm in the solar system. The Great Red Spot is a single hurricane, turning slowly in Jupiter's southern half, and it is wide enough to swallow the whole Earth. It has been turning for centuries. People watched it through their telescopes 300 years ago, and it was old even then. Its winds run at some 600 kilometers an hour, and its clouds heap up in ridges and hollows the way weather does anywhere, except that here the weather is the size of a planet, and it never stops. The spacecraft photographed it as nothing ever had, and watched it churn slowly across turning after turning of Jupiter's day. But the giant was not only grand to look at, it was deadly. Jupiter is wrapped in belts of radiation so fierce they would have destroyed any living thing at once. And at its closest, the spacecraft passed through a dose perhaps 1,000 times what it would take to kill you. It came through, but not untouched. The radiation was strong enough to damage some of the photographs even as they were being taken, scratching marks and streaks across the pictures of that violent place. And on its way through, it found something no one had known was there, a thin, dark ring around Jupiter, far too faint to have ever been seen from Earth, circling the planet above its equator. Saturn, it turned out, was not the only world that wore a ring. And then, days after the spacecraft had already swept past and begun to pull away, came the discovery that outshone all the rest. It did not arrive from the cameras in the moment, but from a single photograph studied later, back on Earth, by a navigation engineer named Linda Morabito. Her job was not to hunt for wonders, but to pin down the spacecraft's exact position against the stars behind it. And so, she was studying an image of Io, a small, sulfur yellow moon about the size of our own moon, taken as the spacecraft looked back on its way out. On the edge of Io, rising off the curve of it, she saw a faint, mushroom-shaped smudge. She thought at first it was another moon behind it. It was not. It was a plume, a fountain of material blasting up off the surface and climbing 300 kilometers into space, some 30 times the height of Everest. It was a volcano, an erupting volcano on another world, the first that human beings had ever laid eyes on beyond the Earth. Until that week, most people would have told you the little moons of the outer planets were surely cold and long dead. They were not dead. Io turned out to be the most volcanically alive place in the whole solar system, its face repaved over and over by its own eruptions. If you could stand on it, you would find almost no craters anywhere, only fresh ground. What keeps it molten is Jupiter itself, all that gravity squeezing and releasing the moon on every orbit, kneading it until its insides run hot. The volcano Morabito had found would later be named Pele, for the Hawaiian goddess of fire. And here is the part that still seems almost too neat to be true. Just 3 days before the spacecraft made its closest pass, 3 scientists had published a short paper working out from the raw mathematics of Jupiter's pull that Io ought to be heated from inside, that it might, they wrote, show signs of melting, even eruption. Their paper was barely a week old when Voyager's own photograph proved them exactly right. A prediction made with pencil and equations, and its proof carried home in a thread of radio, had met each other at Jupiter within a matter of days, over a moon that had been erupting unwatched since long before there were any eyes on Earth to watch it. Jupiter had one last thing to give before it let the traveler go. All that gravity, the same grip that crushes the moon Io and could end a human life in a heartbeat, reached out and caught the little machine as it swept by and through it. It came away faster than it had arrived, 10 kilometers a second richer, flung up and onward toward the next world waiting in its path. And that world wore rings. Saturn's rings are the most familiar sight in the whole outer solar system. The thing a child draws when asked to draw a planet. But nothing about that familiar picture prepares you for what they actually are. The spacecraft reached Saturn in November of 1980, and as the rings sharpened in its cameras, the few smooth bands everyone knew from Earth broke apart into thousands upon thousands of separate ringlets, fine and close and countless, like the grooves of an enormous record. They are not solid at all. They are made of ice, numberless separate pieces of it, from grains no bigger than dust to blocks the size of a house, each one a tiny moon on its own orbit, all of them circling together in a sheet so wide and so thin it is hard to hold in the mind. The rings stretch about 250,000 kilometers across, most of the way from the Earth to the Moon. And yet, in many places, they are only around 10 meters thick, top to bottom. Shrink that whole shining sheet down to the width of a football field, and it would be thinner than a sheet of paper. And they were stranger, up close, than anyone had guessed. Dark, ghostly streaks appeared across the rings and then faded, spokes reaching outward like the hands of a clock, cast by something no one could yet explain. Here and there, tiny moons rode along the edges of the rings, their gravity herding the ice into narrow braided bands like sheepdogs keeping a flock in line. For all that people thought they knew Saturn, the spacecraft found a world still full of things unaccounted for. But Saturn itself was not the reason the traveler had been sent on this particular path. The reason was a moon. Titan is the largest of Saturn's moons, larger, in fact, than the planet Mercury. And it is the only moon in the solar system wrapped in a real atmosphere, a thick, heavy air, mostly nitrogen, not so unlike our own. That alone made it one of the great prizes of the mission. But there was more to the hope than that. In Titan's cold air there is methane and other carbon-rich compounds drifting and reacting in a slow chemistry that some believed might echo the chemistry of the young Earth in the ages before there was any life at all. To see Titan up close was, perhaps, to look at a frozen version of our own beginnings. So the spacecraft was aimed to pass very near it, and when it arrived, Titan gave up almost nothing. Try to picture it, a world larger than a planet, and not one glimpse of its surface, because Titan is wrapped from pole to pole in an unbroken smog of orange haze, and the cameras simply could not see through it. Beneath that veil lay a surface colder than anywhere you have ever stood, or ever could, around minus 180 degrees, cold enough that the rock is hard as steel, and the rivers, if there are rivers, run with something other than water. The spacecraft had crossed the solar system to look at Titan, and Titan kept its face hidden. And here is the quiet turning point of the whole story, the moment, though no one watching a photograph of an orange moon would have felt it, that decided everything the traveler would ever become. To make that close pass by Titan, the spacecraft had to fly a very particular path, sweeping close past the moon and then in behind the great ball of Saturn. And the pull of Saturn, taking hold of it there, did not fling it onward to another planet the way Jupiter had. It threw it upward instead, some 35 degrees up and out of the flat plane in which all the planets circle the sun. In a single pass, the traveler was lifted clean out of the road every world runs along and set climbing into the empty sky above it. That is a road with no more planets on it. From the instant it left the plane, Voyager 1 could reach no other world, not Uranus, not Neptune, none of them. To have this one look at Titan, the mission had spent every planet that lay beyond Saturn. It was a bargain made on purpose and made with open eyes. Titan was judged worth more than all the worlds it cost, and the cost was carried by the twin. Voyager 2 had been held back on a gentler path, the one that kept the old Grand Tour alive, and in the years that followed it went on alone to the planets its sister had given up, reaching Uranus in 1986 and Neptune in 1989, while Voyager 1 climbed away into the dark. So this was the fork in the road, and the traveler took the branch that led off the map entirely. It has never come back down into the plane where the planets and the Earth beneath you still circle the sun. It was climbing now into a part of the sky no machine had ever entered, and 10 years on from far out in that empty height, it would pause just once and turn its cameras around for a last look back at the place it had come from. 10 years passed. The planets fell away behind it, one by one, until there were none left ahead, and the traveler climbed on alone through the empty sky above the solar system, further out than any of the worlds it had visited. By the winter of 1990, it was some 6 billion kilometres from home, 40 times farther from the sun than you are right now, so far that the sunlight reaching it had grown faint and its own warmth was beginning to run low. The cameras that had shown us Jupiter's storms and Saturn's rings were about to be switched off for good, to save what little power remained for the long dark work still ahead. Before that happened, one of the people who had made the record, Carl Sagan, asked for one last thing. "Turn it around," he said. "Before we close its eyes, let it look back and take a picture of where we live from all the way out here." It was not an easy thing to ask for. There was almost no science in it. From 6 billion kilometers, the Earth would be nothing but a dot, and aiming the cameras back toward the sun risked burning them out. But in the end, on the 14th of February 1990, the spacecraft turned and looked homeward and did what nothing had ever done before. It photographed the planets of the solar system from the outside all at once, 6 of them, caught in a long sweep of 60 separate frames, a family portrait of our own worlds, tiny and scattered across the black. And in one of those frames was the Earth. It is not a world in that picture. It is not blue and white and turning. It is not the globe you have seen from space 100 times. It is a single point of light, smaller than the smallest thing the camera could truly make out, about 1/10 of 1 pixel. And by pure chance, it sits inside a stray band of sunlight scattered across the lens, as though the picture had been lit for it on purpose. That is all our planet is, seen from that far away, a single dim speck in a shaft of accidental light. And yet that speck is everything. Everyone who has ever lived was there, on that one point of light, and you, lying wherever you are tonight, are somewhere in it too. From 6 billion kilometers away, the whole human story shrinks to less than a single dot in a photograph. The light that carried that picture home had left the Earth about 5.5 hours before the camera caught it, and had crossed all 6 billion kilometers to be seen. Then, 34 minutes after it took those last frames, the cameras were switched off. It was done to save power, and there was little sense in keeping them running with no more worlds ahead to see. But it marks a quiet ending all the same. For 13 years, the machine had been our eyes in the outer dark. It had watched a volcano fountain off a moon, and a storm broader than the Earth, and a sheet of ice 250,000 kilometers wide. Now it would never see anything again. The last picture it ever made was that one. The whole of home shrunk to a pale point, held for a moment in a chance ray of light, and then let go. With its eyes closed, there was nothing more to look at in any case. Ahead of it lay no worlds, no colour, no light but the fading sun at its back. Only the slow thinning of the sun's own breath remained. And somewhere in the dark ahead, the edge of everything the sun still ruled. For all the years it had been travelling, the spacecraft had never really been moving through empty space. It had been swimming the whole time in a wind. The sun does more than shine. It breathes out, a steady gale of tiny particles, thin gas stripped of its charge, streaming away in every direction at more than 1,000,000 kilometers an hour. This solar wind has been blowing since the sun first lit, more than 4.5 billion years ago, and it blows so hard and so far that it carves out an enormous bubble around the sun, pushing back the cold gas that drifts between the stars and holding it at bay. Everything you have ever known lives inside that bubble. The Earth and all the planets and the spacecraft itself for every kilometer of its journey, all of it has always been held deep inside the sun's own weather, wrapped in the sun's outrushing wind. But a wind, however strong, cannot blow outward forever. The further it travels, the thinner and slower it grows, until at last it can push no harder against the darkness pressing in from beyond. And somewhere out past the final planet, in a place with no name and no marker, the wind meets that outside pressure and begins to give way, slowing, quite suddenly, from its headlong rush to a crawl, piling up on itself, growing hot and turbulent and strange. There is a name for that place, the termination shock. It is the beginning of the end of the sun's country. The spacecraft reached it in December of 2004, the first thing humanity had ever made to come so far. By then, it was some 14 billion kilometers out, about 94 times as far from the sun as we are, and more than 3 times beyond Neptune, the most distant planet there is. The sun's wind, in other words, reaches 3 whole planets worth of distance past the edge of the planets themselves before it finally slows. It is more than you can really picture. A single ordinary star, blowing a bubble wide enough to swallow its entire family of worlds many times over, and one small machine out near the rim of it, still going. By then, too, the traveller was growing old. It had been flying for 27 years, and its nuclear heart was a little cooler with each of them, its power quietly ebbing, thinning in its own way, just as the sun's wind was thinning in the great emptiness around it. There was nothing to see at the crossing, but then the spacecraft had been blind since it closed its eyes over the Earth 14 years before, and this, as it happened, was the very region it had been built for. Long ago, its makers had given it senses for exactly such a place, instruments to feel the push of the wind, to count the particles hurrying past, to measure the sun's magnetism far from home. Its eyes had been for the planets. These quieter senses were for the emptiness between and beyond them. Now, with the worlds all behind it, they were all it had, and all it needed. It did not see the termination shock, it felt it. The wind that had been at its back for 27 years, suddenly slackening and swirling, turning over on itself like a river spreading out where it meets the sea. Beyond the shock lay a stranger country still, the outermost skin of the sun's bubble, where the worn-out wind eddies and doubles back and slowly loses itself. The spacecraft would take years to cross it, drifting through some 27 times the distance from the Earth to the Sun, another whole Neptune's orbit laid end to end, with no landmark and no edge, nothing at all to mark how far it had come but the slow, patient reading of its instruments and the ever fainter murmur of the wind around it. There is a particular loneliness to that stretch of the road. The planets were behind it. Home was a point of light too small to pick out, and the last thing still reaching out to touch it, the wind off its own star, the very breath of the sun that warms the earth and everything alive on it, including you tonight, was fading away to almost nothing around it. It was coming, at long last, to the shore of everything the sun still held. But reaching a shore is not the same as crossing it. The wind had grown faint and slow and old, and still, a fading wind is not a border passed. The true edge of the sun's realm was yet ahead, and when the spacecraft finally came to it, that boundary would make itself known, not by anything it could see, and not by any line drawn across the dark, but by a sound. There was one thing the spacecraft could not do, out there at the edge. It could not taste the wind. The single instrument built to sample the sun's wind directly, to reach out and measure the thin gas as it flowed past, had failed back in 1980, more than 30 years before, and had been silent ever since. So, when the traveller finally came to the true edge of the sun's country, it would not be able to feel the wind simply stop. It would have to hear the change instead, and it could still hear. Among the senses its makers had given it was one that could sense the faint ringing of the charged gas all around it, the way that gas hums and quivers when something sets it going. In 2012, the sun threw off one of its great storms, a burst of particles hurled outward across the solar system. About a year later, that burst reached the spacecraft far out in the dark and struck the gas around it and set it ringing. The note that gas rang at told the whole story. The pitch of that ringing depends above all on one thing: how thick, how dense the gas is. And the note the spacecraft heard was high, far higher than the sun's thin, outbound wind had ever sounded. The gas out there was dozens of times denser than anything inside the bubble. It could mean only one thing. The spacecraft was no longer swimming in the sun's wind at all. It had come out the far side of the bubble, into the colder, thicker gas of the galaxy itself. You can even hear it in a way. Scientists turned those faint vibrations into sound, and what comes out is a thin, rising whistle, eerie and small, the note of the gas between the stars, ringing around the most distant thing we have ever made, When they worked backwards from that sound, they found the actual crossing had happened months earlier on the 25th of August, 2012, and no one on Earth had felt a thing at the time. There had been no wall, no line, no marker, only somewhere in the dark, the sun's wind quietly failing and the gas of the galaxy quietly taking its place. For the first time in all of history, something built by human hands had passed out of the sun's own atmosphere and into interstellar space. Nothing we had ever made had been there before. It is a fact repeated all the time, and nearly as often gotten wrong. You have very likely heard it said that, in 2012, Voyager left the solar system. It is a lovely idea, but it isn't quite true, and the truth is stranger than that, and worth understanding. What the spacecraft crossed was the edge of the sun's wind, the outer wall of the great bubble the sun blows around itself. That bubble is the sun's atmosphere in a sense, and yes, the traveller had left it. But the solar system is far, far larger than the sun's wind. The sun holds things in its grip that lie enormously farther out. Above all, the Oort cloud, a huge faint shell of frozen comets, uncountable billions of them, wrapped all the way around the sun and reaching perhaps as much as halfway to the nearest star. That shell is still the sun's country, held by the sun's gravity, and the spacecraft has not come anywhere close to it. Here is the measure of it. Voyager will not even reach the inner edge of that far shell of comets for something like another 300 years. It will not pass beyond the outer edge, will not truly, finally clear the sun's gravity and leave the solar system behind, for perhaps 30,000 years more. In all its decades of flight across all those billions of kilometers, it has covered less than 1 part in 100 of the distance to the real edge of the sun's family. It is far closer to home than the word interstellar makes it sound. It has stepped out of the sun's breath. It has not stepped out of the sun's reach. So this was not a departure, exactly. It was a shoreline, the place where one great ocean, the sun's, gives way to another, the galaxies. The traveller had waded out of the shallows of its home star and into the open sea beyond, while remaining still within the wide waters the sun commands. There was no gate to pass through, no border guard, nothing to see, only a change in the pitch of the emptiness and the fact, quiet and enormous, that a machine from the third planet of an ordinary star was now the first of its kind adrift among the stars themselves. It had crossed into the space between the stars. And the most astonishing part of all is this. More than 40 years after it left, and 25 billion kilometers away, it was still finding a way to tell us so. All of that has already happened. The launch, the planets, the long climb out of the sun's wind, every bit of it is behind us now, decades in the past, which leaves the strangest question of the whole story, and the one worth ending up on. Where is the spacecraft tonight? And how, after everything, are we still talking to it? It is very far away. As you lie here listening, Voyager 1 is around 25 billion kilometers from Earth, something like 170 times farther from the sun than we are. And it is still moving outward, still climbing, at roughly 17 kilometers every second. But the number that says it best is not a distance in kilometers at all. It is a distance in time. Its radio signal, traveling at the speed of light, the fastest anything can go, now takes almost a full day to reach us, close to 24 hours one way. Voyager is nearly a light day from home. Send it a question tonight, and the question will not arrive until tomorrow. Wait for its answer, and the answer will not reach you until the day after that. To ask this machine a single thing and to hear back is a conversation that takes the better part of 2 days. And the wonder is not only that it is out there, the wonder is that we can still hear it at all. By the time the spacecraft's signal has crossed all that distance, it is almost nothing. A whisper of radio so faint that it arrives carrying less than a billionth of a watt, fainter than the natural static that fills the sky. To catch it, we aim the giant dishes of what we call the Deep Space Network. Great steel bowls 70 meters across, spaced around the planet so that at least one is always turned to the right patch of sky. And we listen. And night after night, out of all that emptiness, they find it. The small, steady voice of a machine broadcasting on about 20 watts of power, less than the bulb in a bedside lamp from beyond the edge of the sun's wind. But the most remarkable thing of all is not that we listen to it. It is that, from here, we can still reach in and mend it. In November of 2023, something went wrong. Voyager was still calling home, still transmitting faithfully, but the signal had turned to nonsense, page after page of meaningless noise, as though the old machine had begun to talk in its sleep. To find the fault, the engineers sent a command asking the ancient computer to read its whole memory back to them. And in that readout, at last, they saw it. A single chip of memory. One small piece of 1970s hardware holding a fraction of the computer's few kilobytes had simply died, 46 years into a mission built to last 5. Perhaps a passing particle had struck it. Perhaps it had just worn out. Either way, the words stored there were scrambled, and everything the spacecraft tried to say came out broken. Nothing could be replaced, of course. There is no reaching a failed part 25 billion kilometers away. So the engineers did the only thing they could. They rewrote the spacecraft's mind around the wound. They took the lost instructions, tucked them in pieces into other corners of the memory that still worked, and taught the old computer where to find them now. And they did all of it across the light day, sending each careful command out into the dark, then waiting the better part of 2 days to learn whether it had worked or whether they had made things worse. Imagine sending help to someone in trouble and then not knowing, for 2 whole days, whether it had even arrived. By the spring of 2024, the spacecraft was making sense again. By that summer, one by one, all 4 of its instruments had come back, and it was doing science once more. People on Earth had reached out across the emptiness and healed a failing mind they could not touch, could not see, and would not hear answer for 2 days at a stretch. They were not finished either. Voyager keeps itself pointed at us with tiny thrusters, little puffs of gas that nudge it over and over, so its dish stays aimed at home. And across the long years, those thrusters had slowly been clogging shut. So in early 2025, the team reached back even further, waking a set of thrusters that had been given up for dead since 2004, more than 20 years cold, coaxing warmth and life back into them from a light day away, in case they were ever needed. And the thrusters answered. Even now, after everything, the machine still does as it is asked. There is a devotion in all of this that is easy to miss. Somewhere on Earth, in ordinary rooms, people are still spending their working lives listening for one small spacecraft, learning its failing body by heart, nursing it gently onward. And many of them are tending a machine that was launched long before they were born. We can still hear it, but every year the voice grows a little fainter, because the heart that has kept it warm and speaking for half a century is gently and unstoppably running down. In the end, it all comes down to the heart. Everything the spacecraft still does, every reading it takes, every heater that keeps its own body from freezing solid, every faint word it sends home, runs on the warmth of that one small piece of plutonium. And the plutonium is running out. It has been cooling since the day it was sealed in, giving up about 4 watts of power every year, quietly and without pause, so that by now the machine makes less than half the power it had at launch. There is a little less to go around each year. And so, slowly and deliberately, the old traveller is being asked to do less. The way to keep it alive longer, it turns out, is to let it feel less. One by one, to save power, its senses are being switched off. Early in 2025, The engineers shut down the instrument that had spent nearly 50 years counting the high-energy particles racing in from the wider galaxy. The following year, they switched off another, the one that measured the charged particles drifting past. Each time, a sense that had worked without fail since before most of us were born went dark, so that the few still working might carry on a little longer. There is a strange tenderness in it, dimming an old traveller's senses, one at a time, to buy it a few more years. Two senses remain now. It can still feel the magnetism of the space around it, the faint field that threads the emptiness between the stars. And it can still listen, with the very instrument that once heard the plasma ring as it crossed the shoreline of the sun's realm years ago. So there it goes, nearly blind and nearly deaf, an old machine alone in the dark, still faintly feeling and faintly hearing the space it moves through and sending back the little it can still gather. For a while yet, it will manage even this. Then there will be power enough for only one of those senses, and then, in time, for none. But even a spacecraft with nothing left to sense can still tell us one thing: how it is faring. Long after the last instrument goes quiet, it should be able to keep sending the faintest report about itself, its temperature, its fading power, the plain fact of its own survival, a kind of pulse, saying only that it is still there. It can keep that up, the engineers believe, into the 2030s. And then, sometime around the middle of that decade, when the heart has cooled past the last threshold it can cross, even that will end. There will simply not be enough power left to send anything at all. It is worth being clear about what that ending will be like, because it is gentler than it sounds. The spacecraft will not know. It will not feel itself grow cold, nor notice its senses going out, nor understand that it has fallen silent. To the very last, it will keep doing the one thing it has always done, holding its dish steady, aimed at a pale point of light that is the Earth, and sending, whether or not anyone is still listening, whether or not you or anyone is awake to hear. There will be no final cry, no dramatic breakdown, nothing you could mark as the moment it died. One day, we will send a command, and no answer will come. You will not hear it die. You will only one day stop hearing it. And set against everything that came before, there is nothing sad in that, or nothing only sad. This is a machine that was built to last 5 years and to visit 2 planets. It has lasted nearly 50 and crossed clean out of the sun's own realm, and it is still, tonight, sending word. It has already given far more than anyone ever thought to ask of it. Even now, as you settle towards sleep, it is out there in the cold and the quiet, faithful to a task no one alive remembers assigning, its small, warm heart still beating, still spending itself, kilometre by kilometre, on the long road out. One day soon, the last word will arrive, and after it, nothing more. But the silence, when it comes, will not be the end of Voyager. It will only be the end of the part of the story that we are given to hear. When the last signal fades, nothing else about the spacecraft will change. It will not slow or turn or stop. There is no fuel left to steer it, no destination waiting ahead, and almost nothing out there to catch hold of it. So it will simply keep going, exactly as it goes now, silent and unaltered, into a future measured not in years or lifetimes, but in millions of years. And it will not be going anywhere in particular. That is one of the strangest things to understand about it. We tend to picture a spacecraft as something aimed, sent to a place, arriving somewhere, met at the far end. But Voyager is not aimed at any star. It is only falling outward, along the line the planets set it on all those decades ago, through a region of the galaxy that is very nearly empty. In about 40,000 years, around the year 40,272, if anyone should still be keeping such a calendar, it will drift past a dim red star named Gliese 445, The nearest it will come to any other sun for tens of thousands of years. And even that close approach will leave it about a light year and a half from the star, far enough that the star would show as nothing more than a bright point in its sky if it had any eyes still open to see. That is how empty the space between the stars truly is. The nearest star to our own sun lies more than 4 light years away, and at 17 kilometers a second, fast enough to carry you across an entire continent in a few minutes, Voyager would need something like 75,000 years merely to cover that one gap. And it isn't even going that way. It will spend those tens of thousands of years crossing almost nothing. No worlds, no landfall, no light, but the cold, distant glimmer of stars it will never reach, scattered so thinly through the dark that it may pass its whole existence without ever coming truly near a single one. In time, it will settle into a slower rhythm still. Like our sun, and like very nearly every star you can pick out on a clear night, Voyager will begin to circle the heart of the galaxy. One small object carried along in the great, slow wheel of the Milky Way, completing a single lap about once every 225 million years. It will hold to that orbit not for centuries, and not for mere thousands of years, but for billions, turning and turning, long after the sun that made it has swollen and cooled and died. And through all of it, the drifting, the passing stars, the slow turning of the galaxy, the golden record will ride along at its side, very nearly untouched. Out in that emptiness, there is no rain to rust it, no wind to wear it away, no ocean to swallow it, no war and no weather and no careless hand to break it. There is almost nothing at all to age it. It was built to last 1 billion years, and out there it may last far longer than that, which means the music is still on it. The 55 spoken greetings are still on it. The whale's long song and the small voice of a child saying hello from the children of Earth, and the heartbeat of a woman recorded in the days she first fell in love. All of it is still there, and stays there, and could still be played long after the pyramids have worn down to sand, long after the continents have slid into new shapes with new names, long after the last of us is gone. Almost certainly, no one will ever find it. The space it crosses is too empty, and the odds are far too long, but it will carry its message onward all the same, unread and unbroken, for as long as it endures, which is to say, for very nearly forever. The traveller falls silent. The message does not. And so, having followed it all the way out to the end of its road and beyond, we come back at last to where we began, to the room you are resting in tonight, and the small blue world turning quietly outside your window, and to the question this whole long journey has been asking, softly, the entire way. We can leave that question hanging a little longer. Before we ask what any of it means, it is worth pausing quietly to remember everything this one small machine has been. It began as a line of numbers on a page, a rare arrangement of planets that opens only once in 175 years, noticed by a young man at a desk in the summer of 1965. It was given a body of foil and wire no bigger than a car, and a heart of warm plutonium that had already begun to die the moment they sealed it in. And before we sent it away, we bolted our whole world to its side, our music, our voices, the recorded beat of a human heart. Then, on an autumn day in 1977, we lit the engines and let it go, and it rose up off the earth and never came back. It went out and did things nothing had ever done. It caught volcanoes throwing fire off a moon of Jupiter and watched Saturn's rings break into 1,000 turning ribbons of ice. At a veiled orange moon called Titan, it came to a fork in its road and gave up every remaining planet for one close look. And in that choice was flung up and out of the flat plain where the worlds run, onto the long road into the dark. 10 years later, from far out in that dark, it turned its cameras around one last time, took a single photograph of home, and then closed its eyes for good. It reached the place where the sun's own wind dies away. It became the first thing we ever made to slip out of the sun's country entirely and into the space between the stars. And through all of it, its heart cooled a little more each year, and its senses went out one by one, and still it kept faithfully calling home, as it is, faintly, tonight. That is a great deal for one machine the size of a car, but it is not, in the end, what Voyager will be remembered for, because the two things it is most loved for are not really about Jupiter or Saturn or the far edge of the sun's wind at all. They are about us. We built it to go out and look at the universe, and the deepest thing it ever did was turn around and look back at the ones who had sent it. Think of that last photograph again. The whole of the Earth, and everyone who has ever lived upon it, gathered into a single grain of pale light, very nearly lost in the glare. And think of the golden record still riding on its side, the Bach and the blues, the 55 greetings, the child's small hello, the heartbeat of a woman in the first days of love. We told ourselves we were sending that record out to introduce ourselves to some stranger among the stars. But in choosing what to put on it, in deciding what, out of all of human life, we most wanted to say, we were not truly writing to them at all. We were drawing a picture of who we hoped we were. The farthest thing we have ever made turned out, in the end, to be a mirror. We sent it to see the cosmos, and what it has shown us, most of all, is our own face. And the people who made it are in that picture too. Carl Sagan, who gathered up our music and pressed at the last for that look homeward, has been gone now for 30 years. Ed Stone, who watched over the mission for half a century, from years before it launched almost until the end of his own life, is gone as well. Many of the hands that built it are old now. One day all of them will be still. And yet even lately, when the old machine's mind faltered far out in the dark, people reached across that impossible distance to save it, sending careful commands into the night and waiting 2 whole days each time to learn whether they had worked. There is a kind of love in that. We have never quite been able to let it go. So here we are, back where we began. It is late, you are resting, and the small blue world outside is turning slowly toward morning. And out there, 25 billion kilometres away, nearly a full day at the speed of light, the machine is still going. The heartbeat recorded on a June afternoon in 1977 is still moving outward through the night. The child's hello is still moving outward. The record, gold and patient, is still whole, still waiting for a reader it will almost certainly never meet. And none of it asks anything of us. It does not need us to watch or to understand or even to be awake. It simply goes on. And that, perhaps, is where the question quietly answers itself. For 50 years, Voyager has been teaching us, gently, how small we are. A single speck of light in one photograph. One brief human life, set against 40,000 years, against 100 million, against the slow and enormous turning of a galaxy. It would be the easiest thing in the world to feel diminished by all of that, to look out at so much distance and so much time and feel like nothing at all. But there is another way to hold it, and it may well be the truer one. That small speck of pale light is the one place we have ever found where the universe has woken up and begun to look at itself. For almost the whole history of everything, the cosmos simply went on, burning and turning and unwatched, with no one anywhere to see it. And then, in one thin sliver of time, on one ordinary world, the very stuff of that universe arranged itself into beings who could look up into the dark and measure it and ask what it meant. Think how unlikely that is, that out of all those silent burning stars and all the empty space between them, there should be somewhere a small warm thing that knows any of it is there. We are small, but we are the small thing that noticed. We are the part of the universe that learned to wonder how large it is, and then, not content merely to wonder, built a machine of foil and wire and sent it out to find the far edge, carrying in its chest the sound of a beating heart. That is the answer to the question this whole long journey has been asking. What does any of it say about who we are? Not that we are grand or lasting or important to the wider dark. It says that we are small and brief and easily frightened, and that we look up anyway. It says that when we finally built a thing that could leave and never return, we did not fill it with our weapons or our boasts or our conquests. We filled it with music, and a whale's song and a child's voice, and the pulse of someone who had just fallen in love. The farthest thing we have ever made carries, at its very center, the gentlest thing about us. So let that be enough for tonight. There is nothing here you need to solve, and nowhere you need to be. The traveler is out there in the quiet, and it is at peace, and it will still be going long after you have closed your eyes, through the rest of this night and every night that follows, and on into years that none of us will ever see. Rest now. Let the room grow dark and soft around you, and let your breathing slow. Somewhere out past the planets, past the last thin edge of the sun's wind, a small machine is still falling gently outward through the dark, carrying its golden record and its old, faithful heart, further out and further and on. It has been travelling since before you were born. It will be travelling still when you wake. You do not need to keep watch over it tonight. You can let it go and let the whole day go with it. Let all of it go, just for now. The hours behind you, the world outside your window, the wide and turning sky. It will all still be here, turning quietly in the morning. Sleep well. Somewhere out there in the dark, on behalf of every one of us, a small and faithful light is still carrying everything we love, further and further into the night. It is enough now simply to know that it is there. Rest. Good night.